Good morning, class.
Morning,
Morning,
sir.
Good morning. So what was our lesson last meeting?
Our lesson last meeting, sir, was all about rational functions.
So do you have any questions about rational functions?
None, sir.
No, sir.
Okay, very good. So today, let's move on to our next lesson. So our lesson is all about one-to-one function and inverse of one-to-one functions. So reporter, are you ready?
Yes,
So
sir.
please, you may start now.
Hello everyone, I am Isa P. Amod and I will be one of the reporters of one-to-one function. Definition of one-to-one functions. The function f is one-to-one if for any x sub 1, x sub 2 in the domain of f, then function x sub 1 is not equal to function x sub 2. That is, the same y value is never paired with two different x values. Hello everyone, so we are going to report about one-to-one functions. I have here some examples. First, let's guess if these examples are one-to-one functions or not. First, this is our domain here and our codomain. Now we can see that each of the x values is paired to only one y value. So, is it a one-to-one function or not? Correct. This is a one-to-one function. Now, let's go to example B. We can see here that both x values, negative 2 and 2, are paired to y value 4. Is it a one-to-one function or not? No, it isn't. So, I have here two given functions that are represented as ordered pairs. Now, given one, we can see the inputs and the outputs. Now, is it a one-to-one function or not? It is a one-to-one function because there is no two distinct input that correspond to the same outputs. So, given 1 is a one-to-one function. Now, given 2, let us look at the y values or the outputs. We can see here that 7 is repeated. So, this is not a one-to-one function. So, how to determine if a function is one-to-one, if it is represented as an equation. Now, it is already said in the definition that function of x sub 1 is equal to function x sub 2. Then, this becomes 3x sub 1 minus 4 is equal to 3x sub 2 minus 4. Then, we add 4 on both sides, so it becomes 3x sub 1 is equal to 3x sub 2. We divide 3 on both sides, it becomes x sub 1 is equal to x sub 2. Another way, a faster way to determine if a function is one-to-one is to look at the highest degree. If the highest degree of the function is an odd number, then it is a one-to-one. An example of this is this equation. The highest degree is a 1. So, it is an odd number. Now, it is determined as a one-to-one function. Now, let's determine if these given functions are one-to-one. Number 1, f of x is equal to x squared plus 3. Now, you can see that the highest degree is 2, so this is not a one-to-one function. Next, given number 2, h of x is equal to x cubed. So, the highest degree is 3. It is an odd number and it is a one-to-one function. Given number 3, f of x is equal to 3x minus 4. So, the highest degree is 1. So, it is a one-to-one function. In number 4, y is equal to square root of 9 minus x squared. The highest degree in this function is 2, so it is not a one-to-one function. And graph this function, it will not pass the horizontal line test. So the horizontal line test will be discussed by the next reporter.
Hello everyone, I am Michelle Angelique A. Ferrolino and I will discuss about the graph and real-life situation of one-to-one function.
So now, let us proceed to the graph. For example, to identify if this graph is a function or not, we will use the vertical line test. So a vertical line test is a method that is used to determine whether a given graph is a function or not.
Try to get a marker or a pen. Assuming it is our vertical line, we move from here up to here and notices that the line touches the graph once. How? If we put a line in here and assume that this is a vertical line, you can see it has a 1 point, which means it touches the graph only once. So this is a one-to-one function. We move from here up to here, or we can directly apply the vertical line. We notice that there are 3 points in this graph, which means it touches the graph 3 times. So this graph is not a one-to-one function. Another example, we will identify if this is a function or not. Let's use the vertical line test, or apply the vertical line. We notice that there is only 1 point in this graph, which means it touches the graph only once, so this is a one-to-one function.
I believe that you already understand the graph, so now let us move to real-life situations.
Example number 1. The relation pairing a SSS member to his or her SSS number. So this real-life situation is a function. Or a one-to-one function. Each person has a citizenship, but a person can have 2 citizenship, which we call dual citizenship. So this real-life situation is not a function. Hope you understand something about the one-to-one function discussion. Thank you.
Thank you, Amod and Ferrolino. What an excellent work. So now, let's proceed to inverse of one-to-one function. Cocharo and Aliawan, please present your report now.
Since we're done talking about one-to-one function, let's move forward.
So the next topic that we will discuss is all about the inverse of one-to-one functions.
Inverse of one-to-one function. The definition of inverse of one-to-one function is let f be a one-to-one function with domain A and range B. Then the inverse of f, denoted by f raised to negative 1, is a function with domain B and range A defined by the inverse function of y is equal to x if and only the function x is equal to y for any y in B. Finding an inverse of a one-to-one function. The first step is write the function in the form of y is equal to function x. The second step is we interchange the x and y variables. Then the last step is we solve for y in terms of x. Finding an inverse of a one-to-one function. Here we have an example as we find the inverse of function x is equal to x minus 2 over 3x plus 5. So as we all know, the first step is we write the function in the form of y is equal to function x. So as a result, we have y is equal to x minus 2 over 3x plus 5. The second step is we interchange the x and y variables. So as a result, we have x is equal to y minus 2 over 3y plus 5. The last step is we solve for y in terms of x. So what actually happens here is we cross multiply both sides. So as a result, we have 3xy plus 5x is equal to y minus 2. So what actually happens here is we combine like terms. So we have 3xy minus y is equal to negative 5x minus 2. Then we divide both sides by y. Then we have this. Notice how we have 3x minus 1 on the other side. So in order to get rid of that, we have to divide both sides by 3x minus 1. So we have y is equal to negative 5x minus 2 over 3x minus 1. So therefore, we can conclude that the inverse function of x is equal to negative 5x minus 2 over 3x minus 1.
So we already know how to find the inverse of one-to-one function. Let us now proceed to the property of one-to-one function. Property of an inverse of a one-to-one function. Given a one-to-one function of x and its inverse, then the following are true. First, the inverse of the inverse function of x is f of x. This means that the inverse of f of x is the inverse function of x and vice versa. Next is the f of the inverse function is equal to x for all domain of f inverse. Then the last one is f inverse of f is equal to x for all domain of f. Finding an inverse function using the property. Example, let f of x is equal to 2x minus 7 and g of x is equal to x minus 7 over 2. Determine whether g of x and f of x. Example, let f of x is equals to 2x plus 7 and f inverse of x is equals to x minus 7 over 2. So we will use the first property. The property is f of the inverse function is equal to x. So we'll only substitute. So f times x minus 7 over 2 is equal to blank. So the value of f is 2x plus 7, so we will only substitute the value of x to x minus 7 over 2. So we have 2 times the quantity of x minus 7 over 2 plus 7. So we can cancel out here the 2. So we have x minus 7 plus 7 is equals to x, because minus 7 plus 7 is equals to 0. We can conclude that f of x is inversely to each other. So the next property is inverse of f is equals to x. So inverse of f times 2x plus 7. So we will substitute the value of x to the given. So we have 2x plus 7 minus 7 over 2. So we can cancel out here the plus 7 and minus 7. So we have 2x over 2 is x. So we can conclude that f of x is equal to 2x plus 7 and f inverse of x is equal to x minus 7 over 2 are inversely to each other.
Very good STEM student reporters. Let's give them a big hand. What a wonderful presentation. See you on next meeting, and God bless. Hope you understand all the lessons, and please study our next lesson. Thank you.